Alright, so in this problem, I have 9 to the power of x is equal to 36. So, obviously, we want to find the value of x here. So for my solution, I'm going to first start by rewriting my equation. So I have 9 to the power of x is equal to 36. And now, I'm going to take the log on both sides. So I get log 9 to the power of x is equal to log 36. And an important property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. In this case, I have log 9 to the power of x, and I can move x to the front. So this is going to get me x times log 9 is equal to log 36. And this is why logarithms are so important in exponents, because for solving exponential equations, x is an exponent, and we need to bring x down to be a normal term, and the only way we can do that is by using logarithms. Now, obviously I want to isolate x, so I'm going to divide both sides by log 9. So then these two log 9s cancel out, and I get x is equal to log 36 over log 9. Now we want to simplify this as much as we can, so I'm going to rewrite log of 36 as log of 9 times 4. And I have this over log 9. Now, there are two more logarithmic properties that you guys should know. So the first one is that if I have something in the form log of a times b, this is equal to log a plus log b. And the second one is that if I have something in the form log of a over b, this is equal to log a minus log b. Now these two, along with log a to the power of b is equal to b times log a, these are the three basic logarithmic equations that everyone should know. Now going back to our problem, we have x is equal to log 9 times 4 for log 9, and as you can see, we can use our first property here. Log a times b is equal to log a plus b on log 9 times 4. So now we get x is equal to log of 9 plus log 4. Now I have this over log 9. Now from here, I'm going to rewrite this fraction as log 9 over log 9 plus log 4 over log 9. All I did was divide log 9 with both of these terms. Now anything divided by itself is 1, so log 9 and log 9, these two cancel out, and I get x is equal to 1 plus log 4 over log 9. Now from here, I'm going to rewrite log 4 as log 2 squared. So I have 1 plus log of 2 squared over log 9, I'm going to rewrite as log of 3 squared. And the reason I did this was because, remember, this property, log a to the power of b is equal to b times log a. I can move the 2 to the front on both of these, so I get x is equal to 1 plus 2 log 2 over 2 log 3, and now I can cancel out these two 2's. So if I ever have something in the form log a to the power of b over log c to the power of b, these two exponents just cancel out. Now from here, log 2 is equal to 0.301, and log 3 is equal to 0.477. So I have to just plug these back into our original equation. So I get x is equal to 1 plus 0.301 over 0.477. And 0.301 over 0.477 is 0.631. So 1 plus 0.631 is 1.631. So this is my answer. Alright, so in this equation, I have 2 to the power of x squared over 4 to the power of x is equal to 16. So I want to find the value of x here. So for my solution, I'm going to start by rewriting 4 as 2 squared and 16 as 2 to the power of 4 so that all my terms are in powers of 2. So I get 2 to the power of x squared over 2 squared to the power of x is equal to 2 to the power of 4. Now from here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, I can rewrite that as 4 to the power of x, which is equal to 2 to the power of 4. And, oops, sorry, this is not 4 to the power of x, this is actually 2 to the power of 2x, which is equal to 2 to the power of 4. And now from here, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, m is x squared and n is 2x, so I get 2 to the power of x squared minus 2x is equal to 2 to the power of 4. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, m is x squared minus 2x and n is 4, so I get x squared minus 2x is equal to 4. And now if I subtract 4 on both sides, these two cancel out, and I get x squared minus 2x minus 4 is equal to 0. Now from here, to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 2, and c is equal to negative 4. So I get x is equal to negative of negative 2 plus or minus the square root of b squared, so negative 2 squared, which is 4, minus 4 times a, which is 1, times c, which is negative 4, all over 2a, so 2 times 1. And this is equal to positive 2 plus or minus the square root of 4 minus 4 times 1 times negative 4, which is 4 plus 16 over 2. And this is equal to 2 plus or minus the square root of 20 over 2. Now, we can actually simplify this. The square root of 20 is the same thing as the square root of 5 times 4. which we can rewrite as the square root of 5 times the square root of 4. And the square root of 4 is equal to 2, so this is equal to 2 root 5. So now I get x is equal to 2 plus or minus 2 root 5 over 2. And now if I divide both these terms by 2, I get x is equal to 1 plus or minus the square root of 5.